Alright, so we will begin our discussion with that same question. So I'm presuming that you've actually been in class, you've learned something on sets, and yeah, you have an idea of what sets are. Right. Okay. So we will do this together. So don't worry about this. So we'll start with question one. So we'll be going through these questions and we'll learn through the questions. So let me just drag this to the side such that I have more space on my right there to write. Okay, so the question reads, in the Venn diagram below, shade the set B, so this is the set B minus A, then intersect C and complement. So we have to shade this in the Venn diagram below. So now, before you shade, when you're given such a question, you always have to make sure that you try to simplify it into something that you can easily work out, something that even you by just looking you can easily shade that out. So I'll prepare my worksheet, just write it here. I'll write my sketch of that Venn diagram here down. Okay, right, so I have two sets, three in fact. Then, alright, let me just erase. I want this to be a bit bigger. Okay, so I have A, and then I have my B, and then I have my C seated here in my B. Okay, so what do I call that set C? This set which is here seated in the set B, what do I call it? What do I call that set B? C, I mean. Alright, so we call that a subset, eh? So a set that is contained in another set is called what? A subset. So C is a subset of the set B. C is a subset of the set B. Okay, so now, how am I going to solve that question there? Okay, so uh, I will simplify this first part here. So when you have something like here, which is B minus A intersect C. So from set algebra, when we say B minus A, that's the same as writing what? When you are talking of set difference. Okay, yes, that's correct. So B intersection A complement, like that. Then intersect C complement there. So you have something like this. So from here, what do you think we're going to do? What set law can we use to simplify this further? What set law do you think we can use? Okay, we will not distribute here, but instead we will use the associative law. If you can see that, right? Okay, yeah. So let's use the associative law. Since we have intersection here and intersection there, so in whatever ways I will arrange these, uh, that is what associativity. So I can start with writing B first, then I'll say intersection, then I group this A complement intersect C complement, like that. Okay, so now what is this identity here that you see? What is this here? I can write this as well. So I can write that. If you can see, that is De Morgan's what law, right? De Morgan's laws. So I can write that as A union C, then the complement goes what outside, right? Okay, so now I have this here, which is something which is very easy now towards to handle and sketch. So to shade this in the in the Venn diagram, always start with the part which is in the brackets. It will be easier for you. Part which is in the brackets. So that is A union C. So A union C. So which one is A union C? When you look at the set A union C, okay, so A union C, let me just shade it. First to shade A, so meaning the set I'm bringing, so what is inside is just A union what? Union C. That means bringing everything, every element of A and what and C together. So that would be this. Uh, this is the entire A and the entire what? C. So this is A, yeah, A union C. Now there's a complement there. So if it's complement, meaning it's everything outside what this region which we've shaded, but sits in the what in the universal set, right? Everything that is what is not part of this shaded region is going to be the complement of A union C. So meaning all this, let me shade it in yellow. This here, oh, okay. So this is the complement. Since they're asking for complement, so the one in yellow is what will be your complement. So this that I'm shading in yellow there, this is your complement. Uh, that is A union C complement, the one in what in yellow. Then they are saying intersection what B, intersection B. When you see outside here, have an intersection B. Let me use blue for this one. It's a blue color. So what you do is when you see the intersection there, the section B, meaning you shade the what? Shade the set B. So when you shade the set B, then you see where that the lines will cross. Where the lines will cross. So if I was to shade B, this is B. Set B is here. Okay, so set B is here. Right. So now that being set B, you see now where do these blue lines cross with the yellow what lines? Where do these blue lines cross the what yellow lines? Since the yellow lines represent A union C complement. So where they cross, it means what they intersect. Since here we have intersection, so they have to intersect. So where they will cross, that's where they what they intersect. And you can see that they are crossing here. Let me just write this oasis. I'll shade it or everything where they cross in what in red. So it's all this here. This. See here. Yeah. So this is where they cross. So I can even write this separately just like that to have a clear one now since you've worked out that. Okay. Uh, that is too small. Let me just erase. I hope you can still see my screen. Alright. Let me just try to enlarge my drawing there. Okay, I can even erase this one which we've done here. There's no problem, right? Okay, let me erase this here. Okay, like that. Such that I can draw here again. There's more space here. Like that. there, then I have that there, then I have my set C there. So this is C, that is B, and that is A, and that is U, which is the universal set. So shade it in yellow. So my shaded region is this here, from what I found. Okay, is there any question on this one? That's how you shade. Is there any question? Okay, since there's no question, then we move on to the what? To the next part of to the next question that we have. So I'll erase. Let's move on to the next part of the question that we have. So the question says, given given that X is the universal set and A and B are subsets of X, simplify that there which you've been given as far as what as possible. Simplify. Okay, I'm writing on the wrong one. Simplify that which you've been given there in that question. So how are we going to do that? Can you try to do that on your own? So we are simplifying this. Okay, so try to do that. I see what you will get. Okay. Okay, so that's the question that we are solving. Okay, what have you gotten? Oh, you have to be. To finish the exam, you have to be fast. Okay. Okay. All right. Okay, let's solve this. So this is how we are going to solve this. So we have a complement outside there, right? This complement is outside this big bracket here. Yes, there's that complement outside. So we'll start from that complement. Let's distribute the what? The complement. So when I distribute the complement, here where I have A intersect B complement, when I distribute with the complement outside, this complement to what will go right. So I'll just remain with A intersect B. Then this sign is going to change from union to what? Intersect. Yes. Then when I distribute there, so meaning this one A minus B will then have a complement like that. So what do I do next from here? So what I do is I will say A intersect B, then okay, I can write what is inside here, right, as A intersect B complement, then I have a complement there. Yeah, so then I will have A intersect B like that, then intersect, I can what, I can distribute this complement there in this set. So when I distribute that, I will have A complement, then I'll have union. Since this will change here from intersection to union, then I'll have B there. So how do I move from here? So when you reach such situations, so if we had something that, like if we had union inside here and there, you'd have used, and there was a like since we already have these that are the same here, you'd have used at least that law of distribution to say no, we distributed, but now they are different. There's intersection there and there's union here. So when you reach this stage, you just have to what, you just have to you have to use a Venn diagram. So you just draw a Venn diagram like that to have a picture of what you are what you be be doing. So you have A there and B there. So what is what is A complement? So it's saying A complement union B. So A complement is everything outside what? Outside the set A. So meaning here B as well will be what? Will be shaded like that. That is A complement. Now union B. Union B meaning I'm getting the host every element in what? In B, and in A complement I'm putting them together. So meaning even this part here of B will be what? Will be shaded. This is what is representing this side as A complement union B. So from here now, what do I do next? So they are saying this is intersecting with the intersection of A intersect B. So A intersect B. It is clear A intersect B. If you have A here and B, that Kamidu part is A intersect B, right? Uh-huh. That part, the Kamidu part, is the one which is A intersect what B. So now this A, they're saying where does this middle part intersect with what? With this right side, this one which we had there. So if I shade here, I've seen that it only crosses here since I had red lines here and had blue white lines here. So they only intersect on the middle. That's the same part, the middle, right? Okay, so meaning this in short, what I'll remain with here will just be what? A intersect B, since that middle part is what? Is A intersect B. So I would have simplified further like that. Mhm. You won't get, because they've said as far as possible. So this is the furthest you can go. Yes. Okay. All right. All right. So now let's move. Okay. Yes, you can ask. Okay. So you just write this part. Okay. Okay, so yes, like this illustration is for you to see or to understand what is going on. It carries no marks. Yes, so from here, if you could see it, if you could see that it's going to give you A intersect B, then you would have just put it as A intersect B there. Okay, all right. Let's move on now to part B. Okay, so part B says let x equal to, so I have a closed interval, so x is equal to, here it's closed, then negative 5 comma 10, then here it's open, it's an open interval there. So this x should be what? Our universal set. So if x is our universal what? Is our universal set, then we've been given A. We have a set A which has a closed interval there, negative 1 comma 6. Okay, sorry, that there. Okay, failing to up. Okay, so there it is open at what? At the end of A. Then I have my B. You can see what I'm writing here, what B is. Okay, so it is closed on both ends. B is closed on both ends. Then I have C, which is negative 4 comma 7. Then it is closed there. So now they give you those are your sets. Then they say find each of the following sets and illustrate each set on the number line. So what are those following sets? We've been given C minus A intersect what? B. So this is what we have to find first. So now we can simplify this before we even go further. So that will be C intersect A complement like that, intersect what? B. So if you want, you can write the complement alone, intersect there, such that you have C intersecting with B, or B intersecting with C, which is just the same thing. Okay, right, like that. So this will help us towards to sketch, to sketch that. So how do we do that? So it's good to just see exactly what the drawing of everything is plotted on the number line, to have an idea. So if I have this there as my universal set, which is x, it's going here at the far end, the positive, it is 10, and it is open there at 10. Then I have that it is closed here at the other far end, it's going up to negative 5. So this is my universal set x. So then what are those other what sets? So I have negative 1. So let's say negative 1, I have a to be negative 1 up to 6. Let's say it's from here all the way, maybe 6 is here. So that is my set A. So it's open at 6, it's closed at negative 1. Yeah. Then what is my B? My B is negative 2. So negative 2 can be somewhere here. Okay, just write that properly. Okay, so let's say it's close, very close here to 2, to negative 1, I mean. So negative 1 going all the way up to what? 8. Let's say 8 is here. That is where my 8 is. So meaning from here it's going to be closed all the way.
You mean negative 2 to 8, yeah?
Yes, from negative 2 up to 8. That is B, right? Yeah.
Yeah.
So that's going to be closed on both ends. Then I have negative C to be negative 4. So here, let's say I put my negative 4 there. Negative 4 up to what? 7. Up to 7. So 7 is going to be here in between 6 and what? And 8. So at positive 7 it is closed. So here it's closed, and then it is open go at what? Negative 4. Here it's open like that. So this is how this would look if you were to plot them. So that is C. That's how they would look. So now how do we plot those questions? How do we do that part? So we have that this here, we can start from here, right? To say uh, C intersect B. C intersect B. So you have C here and you have B there. So where do those intersect? So these, if you look, it's here, and then there's this part here, like that. Okay, so this part here is where they intersect. So when I look at where they intersect, here I have at negative 2. Here at negative 2 it is closed, and this negative 2 is in C. So meaning that the negative 2 also belongs to the what? To the intersection. So at negative 2 it will be what? Closed. Then here again where this ends, it ends up to 7, and at 7 it's closed, and 7 is in what? Is in B, and it is also in what? In C. So it will be closed at 7 there. Okay, so it's closed there. So now this is my what? My intersection. So if this is my intersection, uh, what is going to be my, how am I going to do this one here? So I have A coat, A complement. So if I have the set A here, so set A here, it is closed at -1, and it is
At
open.
-1. Yeah.
It is open at what? At 6. So
6.
the complement means, so the complement will be, it will be open here at what? -1, going all the way up to what? Since this is a fixed point, I know. Yes. So since this is a fixed, no, in this case it's not infinity because we have a fixed point.
It's closed.
Yeah. So we have a fixed point in the question. We've been given that our universal set goes up to negative what? 5. And -5 is part of that universal set. It's closed, meaning it will also be closed in the what? In A complement. So this is the first part of A complement. That's -5 all the way up to -1. So at -1 it will be open. Then where else? So here, since 6 is not in what? Is not in set A, meaning it belongs in the what? In the complement. Since it's open at 6,
Yeah.
meaning if it's in the complement, it has to be closed at what? At 6. So if the complement to be closed at 6, then it will go all the way up to here. So at 10 here, it will be open. Since 10 is not in the universal what? In the universal set, so it will be open also here. So this is the other part of A what? Complement. So A complement, as you can see from this side, it's moving -5 closed. Then I have -1 there open, union. Okay, union.
Mm-hmm.
There I have, okay, so it's 6, it's closed, right? At 6 closed, it's a sign closed. Then all the way up to what? 10, it is open like
I'm
that.
confused. Why is the 6 closed when it was open?
Okay.
When it's got like, yeah.
All right, so we said, so as you can see here, the 6, it's open in the set what? A, right? It's open in the set A.
Mm-hmm.
So we are finding A complement, meaning all elements that are not in A. So since it is open in at what? At A, it implies that that 6 is not a member of what? The set A, or the interval A. It's not in what? In that interval of A. So if it's not in the interval of A, meaning it belongs to the complement here, meaning it what? Belong to the complement. You understand now?
Understand, yes.
Okay, all right. So that's why we have a close here. So it closes there, then all the way up to 10. So 10 here, since 10 is not part of what? The universal set, meaning it also won't be part of what? Of the complement of what? Of A. So to be open there. So this is a complement like this. This is a
Mm-hmm.
complement. So now we have to find where this is intersecting with what? This. Where this, since this here is B intersect C, or C intersect B, just the same thing, since we know from laws uh, from set laws that this intersection of two sets is what? Commutative. You can, whether you change, you start with C intersect B or B intersect C, it's just the same thing. So where do these intersect is what we have to find. So to find that, we have to plot them. So let me plot them separately. Okay, I have to erase this part just down here. Okay, you keep this here such that you tell me what this is. Okay, I have, let me erase that. So alright, so what is, so I'll draw my line there. Then, as I said, it goes from negative 5, then there goes to 10. It is open there. Okay, that has to be open there. Okay, so it is open there, then it is closed there. Right, so now I need to plot my a complement. So I said, what is my a complement? What did we find the a complement to be? So a complement was going from set 5, right? Negative 5, right?
Yeah, negative 5 to negative 1.
Okay, to negative 1. Is it open at 1? Open, right?
It's open, yes.
Okay, so that would be negative 1. Then from there it goes.
Then union
Mm-hmm.
6 closed.
So at 6 here to be closed. Then
Yes.
open at.
To 10 open.
Okay, so this is a complement. So now I can plot my negative 2 comma 7, negative 2 comma 7. So negative 2 comma 7. Okay, so how do I do that? Just erase this top part here. Okay, so how do I do that? I will have to plot negative 2. So if I say negative 2 is here, negative 2,
Mm-hmm.
so it's closed at negative 2, like that. Then
Yeah,
up
this
to,
was closed.
yeah,
7.
7 there. So there, it's closed as well. So where do these points intersect is what we are finding now. Since this is a complement intersect C intersect B, so that's what we are finding. So
Yeah.
this intersects here, you can see here to intersect, and from there here and there, like that, they intersect. So that's the intersection. So this intersection, how can I write it on, or how do I write that? So I have negative 2. So negative 2 is here, it's closed, and it's in that set there, which is down here in the complement of what of A. So meaning it will also be part of that to be closed there at negative 2. So it will be negative 2. Then at negative 1 here. So negative 1, it's open. So, and there we see that yes, negative 1 is part of B intersect C, but it is open. It is not in what in it is not in A complement. So meaning it won't be part of our intersection. We can't intersect it. So it will be open at negative 1. Then union here, I write my second part. So my second part, I have negative, I have 6. 6 here, it is closed at 6, and 6 is in what? Is in that set B, is in that interval B intersect C, so it will be closed there at 6. Then I have 7 here, it's closed, it's part of B intersect C, and it's also part of that A complement, so it will also be closed at the end there, right? So from here, from here, uh, yeah, you would have found the what they're asking for, because they're saying find uh, each of the following sets and illustrate each on what on the number line. So you found the what the interval, that this is the what the interval. Then you can what illustrate this on a number line. You can draw it separately now. So from here, remember whatever. So what you're showing, like your most key and important works of which are showing, when you show this that you've done this, then when you graph this which were from graphing is part of the marks which are going to be given. Then the last part now, which we're going to sketch, we're going to sketch the last final way. Let me erase this here. I can erase.
Yes, you can.
Alright, so there. Alright, so how do I do that? So I'll draw my line there. So it goes -5, closed there, and open at 10. Then I have that it's -2, -1, then I have 6 and 7. So this last part is just easy. So at -2 it's closed, so I'll draw there. -1 it is open, so I'll open there. At 6 it's closed, and at 7 it's closed. So this is your final answer. Now, yeah, you have found that. Okay, are there any question on this
Mm, no, I don't think so.
one? Okay, all right,
Unless when I try to solve and then I get stuck, I'll send it directly.
all right. So let us now do the last question. The last question. So I'll erase everything. Do the last question there. Do the last question. So I have the last question says B intersect C complement complement. So what can I do here? I know that I can distribute that complement, right?
Yes, you can.
So I'll have B complement that will change from intersection to union
Union C.
to union C. Right. So from here this is very easy since you have B complement and what C. So you already have C. You know what C is, you've been given in the question. Then B complement. So if your B is this. By definition of complement, by definition of complement is anything that is outside what B but sits in the and in the what in the universal set. That will be
Universal set, yeah.
your complement. So from here it means what my universal set goes up to what -5. So -5
-5, okay.
comma. So here at -5, will it be closed or open? Am I having a closed or an open here at,
Closed.
okay, it will be closed.
-5 is closed.
Yes. Then negative, so -2, is -2 closed or open?
Closed.
Okay, it will be open. Since so here since it's closed in B, meaning in the complement. So this is B complement. In the complement
Okay.
it won't be there, so to be open there. Then union, so even here at 8 it will be what? It will be open, comma, then it goes up to 10, and at 10 as well, since 10 is not even in the universal set, it will be open there. So this is my B complement. I already have my A, my C, I mean. So I can now just sketch this. I can sketch this.
Mm-hmm.
So do I do that? So right. So here it is going to be uh, closed at -5. Then I have that it's open at 10. Then to plot this, how do I what plot that? So I will. So it goes from -5. It is closed up to -2. So let's say -2 is somewhere here. Okay, just an approximation. so it is open at 2 there. Then union
Mm-hmm.
at 8, so 8 somewhere close here too. So that 8, so it is open at 8 and open there. So this is my B complement. So what is my C? My C is negative 4 all the way up to 7. So negative 4 here. So it is open at what? Negative 4. Then it goes up to 7. So the 7 is just before at 8. So it is closed at 7. So now this is these are the two verses that you have. These are what you have. So now how do we get our final answer? So it is talking about what it is talking about union in this case, right? It is B complement union C. So everything is now going to what? To come together. Everything is going to what? Come together. So I'll unite everything. So from here I can move continuously. Okay, can move continuously from negative 5 all the way up to 7 there. Negative 5 all the way up to 7. Okay, so remember here in between where you see here, there are values here. You know that?
Mm-hmm.
Yeah, there are values here. 7 point what, point what, point what, point what. So this 7 point what going up to there, these are not, they are not in any of the two sets, right?
Mm-hmm.
So we cannot put them in our what, in our union. But here I can put, since this is in from negative 5 to negative 2, or from negative 2 to negative 5, uh, I have my, that's my B complement, so it will be there all the way even up to here 7, from negative 4 to 7, bringing them all together. So meaning that will just be one part, which is negative 5. Negative 5, it will be closed at negative 5, right? Close it there.
Mm-hmm.
Negative 5. Up to 7, to be closed at what? 7. So it is closed at 7. Then union, since here in between I don't know what these are, so I can't just go up all the way up to 10, since these are not part of any of the two sets. So it's what? Union, where 8 is, so 8, then 10, like that. Okay, you've seen the slight difference with what we've gotten from B complement. It just changed here, in fact. Yeah, so that is your answer there. So then you just show this on what? On a number line. Just graph this on a number line. So
The
I'll,
final answer.
yes, final answer.
Okay.
So let me erase this here.
These questions are involving they deserve more marks too.
Yeah, but you get the hang of it. They You can actually do them faster than this. So
I hope so.
that there, you have negative 5 here and 10 there. So now that will go from, alright, so negative 5 here to be closed. Let's say 7 is there and I have 8 there. So that will go all the way now up to where 7 is and to be closed. Then from 8 to be open up to 10. So this is your final what? Answer to that question. Okay, any question on this one?
No questions.
It is clear.
Yes, it is.
Alright, so our meeting is scheduled to end in the next 5 minutes. since we said we start at 30, then we finish at 15,
Mm-hmm.
30. So I'll send you questions on these. Let me erase my board. I'll send questions